For his extraordinary commitment to the fields of physical science, Michio Kaku has recently affirmed that the James Webb Space Telescope has found 6 enormous galaxies that researchers thought could not exist. These examinations have the potential to open up new aspects in our scientific comprehension of the universe. The discovery is both invigorating and revolutionary, testing existing hypotheses about the formation and evolution of galaxies. It is, therefore, worth keeping an eye on these developments. The affirmation by such a recognized researcher highlights the significance of these discoveries. Michio Kaku is an exceptional figure in the scientific field, a physicist of American and Japanese heritage. He is regarded as an expert in both traditional experimental physics and quantum mechanics. Unlike some more conservative and cautious researchers, Kaku has been receptive to the astonishing results of the James Webb Space Telescope mission. His eagerness to embrace new revelations and share them with the public underscores his commitment to advancing our understanding of the universe. We are pleased that this renowned researcher has chosen to break his silence and openly share what can no longer be denied. The energy and near-enthralled tone of the esteemed physicist are evident in his remarks on the discovery made by the James Webb Space Telescope, indicating that this has been a highlight that has piqued his curiosity. Join us to explore the implications of Michio Kaku's revelation of these 6 massive galaxies. Kaku is a researcher who has always been open to new theories. Throughout his life, he has demonstrated a receptiveness to ideas that challenge the status quo, recognizing that Einstein's theories of relativity and Newton's laws, while fundamental, are insufficient to capture the full complexity of the universe. Kaku understands that the discoveries of the new telescope have the potential to advance the scientific field, even though many of his peers have not yet adopted this view. It is causing concern and uncertainty among the Big Bang proponents and quantum mechanics skeptics. However, this only prompts laughter from Kaku. The JWST has revealed the existence of 6 enormous galaxies dating back to the earliest epochs of the universe. Each of these galaxies contains a greater number of stars than our own Milky Way, despite having formed only shortly after the Big Bang. The team of astronomers who made the discovery has named these remarkable galaxies universe breakers, as, if confirmed, they would revolutionize our entire understanding of the universe. The implications of these findings are significant, suggesting that the universe's early years were far more powerful and complex than previously thought. The theory of the universe's origin tells us that the universe was a chaotic mess after the Big Bang. The first solid objects took countless years to form, and it took many more years for these objects to reach sufficient density and produce light. The formation of complex structures, such as galaxies, was believed to occur much later. Some of the newly discovered galaxies surpass the Milky Way in size, and their enormous brightness indicates that they were likely forming many new stars each year. While our universe forms stars only sporadically, it remains uncertain exactly when the first galaxies formed. Researchers have not yet been able to determine this with precision. The only clear thing is that initially, there may have been only single stars or groups of stars, which eventually merged to form larger structures over time. Dwarf galaxies, the smaller systems, experienced various stages of galactic development and slowly grew, according to past theories. Highly organized and massive galaxies were thought not to have existed at that time, raising the question of whether the universe is much older than previously accepted or whether complex cosmic structures developed much sooner. This scenario is difficult for conservative science to accept, which still finds issues with this model. Several branches of physics strongly resist accepting this discovery and question potential errors in the age estimates. Kaku is aware of this and has remarked that there are numerous models of outdated and flawed hypotheses that stubbornly endure due to the renown of certain researchers. Many of these theories were only discredited when a significant experiment revealed their falseness. Thus, the key word in any science, particularly in physics, rests within the experimentalists who keep the theorists alert and awake. Indeed, on Earth, we have little insight into the true origins of the universe. Kaku's statement emphasizes the importance of ongoing experimentation and validation in the scientific process. The theory of the Big Bang was established in 1927 based on observations of the universe's expansion. These data led to the conclusion that the universe began from a single point and has been expanding ever since. At the time, it was difficult for people and scientists to imagine a universe with a beginning and an end. The idea of a universe that had always existed and was infinite in extent was beyond people's imagination. Even today, scientists still face challenges in understanding it. However, it is crucial to consider these possibilities. Indeed, these new findings do not fit with what scientists have long based their understanding of on the theory of the universe's origins. Nevertheless, science has shown time and again that revision and openness to new ideas are an essential part of the scientific process, as is the affirmation of certain theories and observations. When Einstein was a child, it was believed that the stars and planets were fixed in place in the universe, and these specific arrangements occupied defined spaces. However, we now know that everything in the universe is in motion. Planets orbit, stars move within their galaxies at many kilometers per second, and entire galaxies travel rapidly through the universe, the fate of which we cannot yet predict. This dynamic understanding of the universe challenges long-held beliefs and underscores the need for ongoing inquiry and evolution in scientific thought. Today, scientists are challenged to accept uncomfortable truths and understand that theories are not absolute facts until they are thoroughly tested or confirmed by precise observation. The concept of the Big Bang emerged from the realization that galaxies are moving away from one another, and this distance is proportional to their separation from Earth. This observation, known as Hubble's law, suggested that the universe was expanding. Components such as cosmic microwave background radiation and the redshift of light from distant galaxies, along with other cosmological phenomena, seem to support this theory. However, it is important to remember that in the past, people who believed the Earth was flat and that the Sun revolved around us also had physical evidence for their assumptions until events or technological advancements provided a clearer and more accurate picture. Currently, we are witnessing a similar situation. Scientists anticipated the new James Webb Space Telescope to confirm the assumptions related to the Big Bang. Instead, they have encountered these 6 galaxies that appeared to be impossible. This reminds us that science is continually evolving and that researchers must be open to new discoveries and reevaluate existing theories based on the available evidence. The surprising findings challenge the current understanding and prompt a reassessment of well-established cosmological theories. Scientists use redshift as a tool to determine certain quantities in the study of the universe. Redshift, also known as the Doppler effect, refers to the change in the color of light as the light source and the observer move relative to each other. To understand this, you can imagine stopping and hearing a car approaching you. As the car moves towards you, you hear the engine sound getting louder. However, once the car passes you or moves away from you, the sound changes. This is because the sound of the engine shifts as the vehicle moves. The same is true for light. When a light source, such as a distant star, moves towards us, the light we see shifts towards bluer shades. Conversely, when the light source moves away from us, the light shifts towards redder tones. This phenomenon is called redshift. Physicists have converted redshift values into speeds and distances for measurement in the study of the universe. However, it is important to note that small errors in these measurements could have significant impacts. The measurement methods previously used are currently under review in light of the latest findings related to our universe. It is crucial to consider whether these methods are truly based on redshift errors or whether some scientists are simply denying the facts. This is a question that requires thorough investigation and careful review of the data and methods used in the research. The current examination and reevaluation of measurement methods highlight the evolving nature of scientific inquiry. Thank you kindly for watching the video. As always, we remind you that you can post your questions in the comments box. If you liked the video, remember to hit the thumbs up button, share it so it reaches more people, and subscribe to the channel so you don't miss more content like this. Many thanks for observing, and see you in the next one. This call to action encourages viewers to engage with the content, fostering a community of curious minds eager to explore and understand the latest scientific discussions. The study of our universe, with its vast regions and complex celestial bodies, continues to captivate and challenge researchers across the globe. From the early theories of the universe to the most recent discoveries made possible by cutting-edge technology, each revelation reshapes our understanding of the universe and pushes the boundaries of human knowledge. One of the most significant and enduring questions in cosmology revolves around the origin and evolution of galaxies. Galaxies are vast cities of stars, gas, dust, and dark matter bound together by gravity. Understanding how galaxies form and evolve is crucial not only for unraveling the mysteries of our universe but also for validating or testing existing theories, such as the Big Bang theory. The theory of the universe's origin, proposed almost 100 years ago, posits that the universe began from a single, infinitely dense point and has been expanding ever since. This concept emerged from observations of the universe's expansion and the cosmic microwave background radiation, considered the remnants of the early universe's intense heat and light. However, recent discoveries, particularly those made by the James Webb Space Telescope, JWST, have challenged some fundamental assumptions underlying the Big Bang theory. The JWST, with its remarkable sensitivity and resolution, has identified galaxies that appear significantly more massive and developed than anticipated for their age. One such discovery involves 6 enormous galaxies dating back to when the universe was only 200 to 700 million years old, a mere blink in its 13.8 billion-year history. These galaxies, dubbed universe breakers by the research team, defy conventional understanding as they are already so large and luminous at such an early cosmic epoch. The discovery of these galaxies raises intriguing questions about the rapid development of early galaxies and challenges existing models of galaxy formation. According to prevailing theories, galaxies formed gradually over billions of years through the mergers of smaller structures and the slow accumulation of gas and stars. The presence of these massive galaxies so early in cosmic history suggests a more complex and potentially faster process of galaxy evolution than previously thought. Additionally, the discovery underscores the critical role of technological advancements in reshaping our understanding of the universe. The JWST's ability to peer deeper into space and capture faint light from distant galaxies has allowed astronomers to uncover previously hidden aspects of the universe's early evolution. These observations provide valuable insights into the conditions and processes that governed galaxy formation during the universe's infancy. The implications of these discoveries extend beyond the realm of astronomy. They challenge researchers to revisit and refine existing cosmological models to better account for the observed diversity and complexity of galaxies across cosmic time. Furthermore, they highlight the dynamic and evolving nature of scientific knowledge, where new discoveries can prompt paradigm shifts and open new avenues for exploration. As scientists continue to analyze and interpret data from the JWST and other observatories, the study of galaxy formation remains a vibrant and evolving field of research. Each new discovery brings us closer to unraveling the mysteries of our cosmic origins and understanding the fundamental processes that have shaped the universe as we know it today. In conclusion, while the discovery of these 6 massive galaxies challenges our current understanding of galaxy formation and the early universe, it also represents a significant milestone in our quest to uncover the universe's mysteries. By pushing the boundaries of scientific knowledge, such revelations pave the way for future breakthroughs and deepen our fascination with the vast and intricate tapestry of the cosmos.